Hello and welcome back to Algebra. Today we are going to have our second exam 3 review, and then tomorrow we are going to work on 7.1. Thursday we'll do 7.2. Next week we are going to finish 7.3 and 10.1, which actually ends the course. So the goal for today is to go through again all of the concepts and work out some of the exercises from the review. Maybe we can actually go into the chapter exam, even though I would like you to actually, from the book, take the chapter 5 test on your own and then just look at the back of the book to find the answers and see if you answered all of them correctly. And I'm going to jump into chapter 5 review exercises to solve. Now, there are certain problems that, because we didn't cover all of the sections, there are certain problems that you should be skipping. You should skip anything that doesn't have coefficient. Oh no, chapter 5 is multiplication, so we can do pretty much all of it. We skipped 5, 6. Yeah, we skipped 5, 6. So pretty much all of it, but then in chapter 6 you have to skip a couple of examples. So let's take a look at chapter 5, which is the stuff that is on ways of adding, subtracting, multiplying, polynomials, and all of that good stuff. So I'm just going to run through most of these, not most of it, but some of these. So we're on chapter 5, review exercises, page 367. So I'm just going to pull random problems, and if you guys have any questions, put them in the chat and I will answer those as well. So 3 plus 3 squared minus 3 to the 0. That's something that we are supposed to compute. So that's 3 plus 9 minus 1, because 3 raised to the 0 is 1. 3 plus 9 is 12, minus 1 is 11. So that would be introductory problem. A lot of problems would say simplify expression. Y squared times y cubed. We know the formula that when the base is the same, exponents add. So that's going to be y 2 plus 1 plus 3 is y to the 6. You can also do this in you can also do all of this in little increments, like 2 by 2, right? You do something and then you do more and you do more, but you don't have to, right? You can do everything at once if it's like this, where all of the all of them are the same, so you just go through. Let's see. We did this one last time. Let's take a look at problem 16. Has x squared y cubed raised to the 4th power. Maybe I should be giving you, a little bit of time to try it on your own, and then you can just compare to what I have. So let's see what you're going to get on this one. All right, so this is the one where we distribute the power to each one independently. So you have x squared to the fourth, and then y cubed to the fourth, which gives you x to the 8th and y to the 12. Because in this case we are multiplying the exponents because it's an exponent to the exponent, right? So you have two of them. So let's see what else is good. You can have the entire expression. That's okay. So a plus b squared times a plus b to the fourth. So I'll give you exactly 11 seconds there. Okay, so we are going to have a plus b stays the same because both bases are the same base, right? A plus b. And the exponents add to 6. That's it. Problem 22 of x plus y divided by 2 cubed. So again, if you have any questions, you should be putting those in the chat so that I can see. So we put x plus y cubed divided by 2 cubed. This is going to leave x plus y cubed. We don't do anything there, just divided by 8. Oh, I see a question in chat. The exam 3 will be in Canvas, not on my MATLAB. Because my MATLAB has issues with connection, and the last time for exam 2, half of you couldn't connect. Now, some of you did send me the proof, others did not, but I wasn't able to log on either, so I tend to believe that, right? Canvas is not going to have such issues, which is why exam is on Canvas, will be on Canvas on Friday. Exam 3 on Canvas. And it's going to be Friday noon to Sunday noon. So it's noon to noon. And once you go in there, it will say, well, it's not, there is nothing now. It's going to be under assignments. You will click, right? So Canvas, let me just verify that it's called assignments. I don't want it to be called quizzes or anything like that. I just need to make sure that it's exactly. I haven't used Canvas before. Now I am forced to use it, so I don't want to get anything wrong. So once you go into your Canvas course for algebra, there we go, you will click on assignments, and it will show under assignments as exam 3. So that's where the exam is going to be and you will be able to quickly find it, and you will have again an hour to solve the exam. So just go through the exercises, and then when you're done, you submit. And then I will also I will post in announcements detailed directions about the whole deal. All right, so that's that one. Let's take a look at more problems. Again, if you have any questions regarding any of the problems, which also includes the online homework or anything like that, just make sure you are plugging those into the Canvas, the description. There's way too many things that I'm looking at right now, so just plug them into the chat. Okay, so let's take a look at another example here. They want us to multiply in problem 24 3x times 4x plus x cubed, which would be 12x squared plus 3x to the fourth. So a problem like this, 4x plus x cubed, would be called binomial. That's, another thing that you can be asked to do, to just write the name of it. Problem 36 is asking you to add x squared plus 3x minus 5 to the polynomial 2x squared minus 5x minus 1. We did this in class where we add like terms. So that's going to be 3x squared when we add x squared terms. They are like terms because their variable parts are the same. And then we have 3x minus 5x. That's going to be negative 2x, right? Because it's technically 3 minus 5. And 3 minus 5 is negative 2, right? Because you are subtracting more than what you have. And then finally, we have the constant numbers. Minus 5 minus 1 will be minus 6, because you are making it worse, right? It's negative 5 already, and then we take away one more, making it more negative. Problem 38 is pretty much the same thing, it's just subtraction. And I always encourage students to first get rid of the parentheses, then do that. So that's 2x plus 6 minus 4x cubed minus 6. There we go. Perfect. So we remove the parentheses first. So 4x cubed minus 2x plus 6, and then minus 4x cubed, and then plus 6. Because this negative sign distributes to both of these, changing both of their signs. So positive 4 turned into negative 4, and negative 6 turned into positive 6. So now if you see, these two are the same, so they would cancel. And we are left with negative 2x plus 12. You just have to be a little bit careful. Let's see the next one. A little bit more multiplying. 47 looks sufficiently annoying, with negative AB distributing into a squared minus 2ab plus b squared. You are supposed to plug all of these values, distribute the negative ab to every single one in the parentheses. So we'll have negative a cubed b, because a and a squared, that's 3a's, so it's a cubed. Now minus times minus gives us a plus, 2a squared b squared, because a times a is a squared and b times b is b squared. And finally, minus ab cubed, because b times b squared is b cubed. So a lot of these really cool calculations. You just need to be careful to plug in the right values. Oh, AB, that was question 47. I forgot to write it there. Cool. Let's see something else. What else could we have? Three. That's good. So all of these are distribution or special ones. This is the good batch. Problem 60 is going to have 5x plus 4y times 5x minus 4y. So this one you can either distribute, or if you don't like distribution, if you memorize the formula, right? If you memorize the formula, you can just use the formula and solve it faster, because these are the same apart from the signs, which means it's a difference of squares. That means that it's going to be 25x squared minus 16y squared as the answer. Now if you FOIL, you will also have plus 20xy minus 20xy, and those would cancel. So you have to be careful, right? And I just want to make sure that you understand that 5x plus 4y squared will be 5x plus 4y, 5x plus 4y, and that's a different formula, right? So this one has two plus signs. This one has a plus and a minus. So you have to be careful and look what you have, right? Because the other one is going to be 25x squared plus 40xy plus 16y squared, right? So it gives us a different formula. So the top one, I'll write it in blood, is a plus b times a minus b equals a squared minus b squared, where in this case below is a plus b everything squared to give us a squared plus 2ab plus b squared. All this just because one sign was different. It's two different formulas, right? One multiplies positive with itself, the other one's positive and a negative. So you have to be very, very careful with these things. And I think we are good. We covered the rules of the exponents. Covered this. Maybe I can put in another one with a negative sign, like 68, for instance. I'm not sure what I did last time. So 4 minus a everything squared is going to be 4 minus a times 4 minus a if you want to FOIL, or if you know the formula, it's first one squared, keep the sign, then first times the second double, so that's going to be 8a, and then plus a squared, right? So that's going to be our solution for this. Okay, some review on chapter 6. Just make sure that I am catching everything. So let's take a look at some of the questions from chapter 6. Again, for chapter 6, we only did 4 sections. So we did 6.1, 6.2, 6.4, and 6.6. So we have to be careful what sections we are working on. This is a couple of these. Let's go first and take a look at problem number 4. Is the one of the GCF problems, 6x to the 4th plus 3x cubed minus 12x squared. So when you look at this, each one of these has a 3. This is 3 times 2. This is 3 times 1, right? And this is 3 times 4. So each one of them has a 3. So we can kick 3 out. And each one of these has at least 2 x's, right? This one has 4, this one has 3, right? So each one has at least 2 x's. So now the question is, what are the leftovers? Well, if you take 2 out of 4 x's out, 2 stay. Plus, we take 3 out, we take 2 x's out, so a single x stays. Oh, I forgot a 2 over here. Oops. There's a 2 there as well. The first term, because it was 6. And the last term is negative 4. And all of the x's are taken out. So there are no x's. This is called the GCF. The greatest common factor, and in this case was 3x squared, which is what we pull out in front of the parenthesis. Now we can combine that with other rules, and generally you should always look for the GCF first, like we did in previous 2 lectures. I explained that, or no, three different times. Lecture, and then the overview, and then the review 1. So this is our 4th time talking about the same thing. Let's see, problem number 12 is the spicy one, right? Because it has a lot of terms. That's 2y to the 4th plus 6y cubed plus 2y squared plus 6y. And when you take a look at this, right, the GCF is going to be 2y. Because every term is even a number, and the smallest one is a 2. And all of the y's, they all have at least one y. So we kick out 2y, and we leave the leftovers inside the parenthesis. That's going to be y cubed minus 3y squared plus 2 is out, so just a single y, and then finally plus just 3, because 2 is taken out. So we factor the GCF, and now this is what we have. So now what I'm going to do is I'm going to take factoring by grouping, and I'm going to apply factoring by grouping here. So that's going to be 2y, and I'm going to we can rearrange this into y cubed. Oh, something is wrong with my signs. Did I copy this right? Ah, that's a plus. Okay, they're all plus signs. So we can group together y cubed plus 3y squared. And then in a second group, we can put y plus 3. So from the first group, we can pull out y squared as a GCF, leaving us with y plus 3. And on the second one, we have nothing to pull out, so you can just pull 1. That's okay, right? You can pull 1. There's nothing to pull out because y and 3 are not the same terms. They have nothing in common, but number 1 is always, out there. So now we copy the 2y. When you take a look, this and this is the same. It's common. So we can pull those two together into y plus 3, and the leftover is y squared plus 1, which is the other stuff. Y squared plus 1. And that takes care of that problem. It's longer, right, factoring, but we had 2 factorings that have been done at the same time. One was factoring by grouping, and the other one was factoring by GCF, right? And you always start with GCF. You always ask yourself, is there something common that I can pull out? Then you go factoring the rest. In the next section, 22, right, we are playing with numbers. Oh, I didn't give you the page. That's 428. Now we're on page chapter 6. Where did I start? Chapter 6. There it goes. Page 428 on. All right, good. Problem 22. X squared minus x minus 42, right? We're supposed to factor. All of the chapter 6 is factor, factor, factor. So what we do is we go and factor the expression. We're going to take a look at the form, right? And the form is clearly. I always say clearly. Nothing is clearly. So the form is one of those forms where we have to do the factors of 42. In this case, negative 42. So that's 1 and 42. One of them should be negative. 2 and 21. And then 3. 3 works because 42 is divisible by 3 because 4 plus 2 is 6, right? So if the sum of the digits is divisible by 3, the whole number is divisible by 3. So that's going to be 14, so negative 14. 4 doesn't work, 5 doesn't work, and then 6 and negative 7. Oh, perfect. There it is. Because 6 plus negative 7 is equal to negative 1, and we need negative 1 on the middle term. Excellent. So the answer is x plus 6, x minus 7. That's it. All right, so let's see what else is there. We have these are all pretty much the same. So if you run into something that doesn't look like, but it's close, maybe by factoring you can, or rearranging, you can make it. So here is this one, right? The issue with this problem is that it's all done in backwards order, right? You're supposed to have your x squared term, right, with the highest exponent first. So you rearrange this, and then you run into another problem. And that problem is that it's negative, right? And for our purposes, right, our formulas and everything, they're asking for positives. So we have to go and do the positive. So we can achieve that by factoring negative 1. So if I factor negative 1, it will just change all of the signs. And so if I put negative 1 in front, and I'll have x squared minus 2x minus 24. So now we have to factor negative 24. which is 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. Aha! Right there. 4 and negative 6, because 4 plus negative 6 is negative 2, and that's what we need. We need negative 2. So, negative 1, x plus 4, x minus 6. Now, some people would just write it as negative x plus 4, x minus 6. So, that's that. Some of the special factoring from 6.4, like a problem 48, 100a squared minus 81b squared, that's just right, 10a minus 9b, 10a plus 9b. This is difference of squares. So we have the formula, the same formula we had earlier, is just now backwards. Let's see what else. Oof. 64. No. We didn't do 6.5. We did 6.6. So let's take a look at another one of these. So 4x squared, that's problem 51. 4x squared minus 12x plus 9. When we factor this one, remember what we said? If you have perfect squares, front and the back, right? We attempt to write the problem. So square root of the first, 2x. Sine of the second is minus. Square root of the third is 3. Everything squared. And then we check middle term. 2 times 2x times 3 is altogether 12x. We do have 12x, so we're good to go. All right, so this is the actual answer. Sometimes it doesn't multiply, and when it doesn't multiply, right, when this and this don't match, then that's wrong. You have to be very careful. This is the answer for factoring only if these two are the same. If you have a different value there, well, it's not going to work. Then you have to use the other methods if it doesn't work. And what's left is to practice a little bit of these equations, right, from 6.6. Some problems, they're already factored for you. You are supposed to apply zero product rule to solve them. And some problems you have to factor and then use the zero product rule. So in this case over here, zero product rule sets each one of these to 0. So we have 1 minus 4x equal to 0. And we have 6 plus 5x equal to 0. So when it says solve, that means it's an equation and you have to solve x equals a number, right? So we'll add 4x to both sides. We'll get 1 equals to 4x. Divide both sides by 4. As you all know it, x equals 1/4. On the other side, take away 6. We have 5x equals to 6. Divide both sides by 5. X equals 6/5. So we had two fraction answers. It's okay to have fraction answers. There is no reason to to panic, right? It's just you have to be careful as you are solving these to, subtract the correct values, add values, and so on. Let's say another one. Problem 74 is one where you have to do work. I'm not sure if I already did this one before. I might have. So I'm going to use the GCF, pull z out, and have z minus 7 as a leftover. Equal to 0. So z equals to 0 is the first answer. And z minus 7 equal to 0. Add 7 to both sides. Z equals 7. So that's what we have for this particular. So every time when you have something, like this, you first make sure it's equal to 0. That was our rule 0. Then decide which factoring you're going to do. When you get factors, set each factor equal to 0, and then finally solve the problem. So they could have, 3, 4, 5 steps. Depends on how long the problems are. So here is, see, I did this problem before. Don't have too many options here because they're mixing also the sections we skipped. So I think I did this one before, but I'll write it again and I'll use x this time. So x minus 14 is equal to 72. I believe I did this already, but that's fine. So it's not equal to 0. That's very important to see. So must make it equal to 0, which means 72 has to go to the other side. Now on this side you have to distribute this x, so you have x squared minus 14x minus 72 equal to 0. So this is what we now achieved. We achieved, right, to have this equal to 0. Everything is on the left hand side, and now we can just use the factoring, right? So I need negative 72. That's 1 and negative 72. 2 and negative 36. 3, because 7 plus 2 is 9, right? So 3 goes into 2, 4, 24. Is it divisible by 4? It is. It is divisible by 4 because 4 goes into 7 once, and then 32 goes 8 times. There is my negative 14. I could go further, but I don't need to because I already found that this is the pair, because 4 minus 18 is negative 16. Sorry, negative 14. I can't subtract 14, which is what we need. So we will have x plus 4 times x minus 14, and this time we also have equal to 0 because this is equation. Now using zero product rule, we separate these equations into two different equations. On the left one we take away 4, and on the right one we add 14. Again, if this is moving a little bit fast, all you need to do is to slow YouTube down, right? You can have a play speed, you can pause. It's just important to get to these equations. And believe it or not, that is the exam. I mean, we went through all of the sections, so you just need to practice more, and then Friday or Saturday or Sunday morning, not in the afternoon. It will be closed. It closes at noon. So Sunday morning, you guys can you know, get some of the you can take the test and just make sure you don't miss it, right? It's not going to give you issues like last time that you can't connect and so on. It's going to be on Canvas. You type in your answers there, and it will be timed. You will have 1 hour. Again, probably like 12 to 15 problems. Again, whatever, I will use the software to tell me what is the appropriate time for you for 40 minutes if you have knowledge, obviously. You know, it should be the same like the last test, except better in terms that you won't have any issues, you know, logging on and stuff like that. So, I will see you all on, I will see you all soon. There is another chat. This differential equations. Okay. All right, guys. I will see you later. Bye.